Thank you so much. All right, let's get started. So thank you very much for joining this session. We are about to share a multi-year project story and try to pack it in like 30 minutes. And I'm Yury from Abound. I'm Principal Solutions Architect there. Abound is the company behind the Crossplane project. And today I'm with my dear friend Gonçalo from Millennium BCP, the largest Portuguese bank. Gonçalo, please kick us off.
Hello. As Yury said, I'm Gonçalo from Millennium BCP, a Portuguese private bank. Today I would like to share a bit of our journey on the development lifecycle of what we like to call the app control plane platform, and how our pains and hurdles with all that, and how Terraform and Crossplane kind of get into that mix. Just before we move on, is it possible we can take like a group selfie? Is it fun for everyone? All right, let's do it.
Do you want to go to the
Maybe here?
center kind of stuff? Yeah.
Can I get everyone?
Can we get like a sign of excitement if you can?
Okay.
Thank you so much. I appreciate it. Thank you.
I tried to get everyone, but my arm's not long enough, so apologies. All right, let's move on. So what is App Control Plane, ACP? Basically, it's a platform to provision environments for the applications or services our internal developers might need to host their applications on. This is just an example onboarding flow on that platform. So basically, we would start with a request from the developer team for a new application that they just magically conjured and decided would be very necessary for the bank. That would be reflected in a application specification that would map out into a desired state that our app control plane would manage. Those would be deployed as simple Kubernetes manifests that would be reconciled via our GitOps tooling. In our case, it would be Flux. And then it would be just the point onto which the application would be hosted on that environment. This is just a few stats to justify this platform. So basically, being in a very regulated bank, we would have to go through a series of very manual labor procedures to host that environment in a manual way. And having that automated saved us a lot of time in the long run. So this is just a few stats of the first year after the initial deployment of that platform. So basically, we saved roughly 15,000 hours, 15,500 hours. 15,500 hours on the developers waiting for their environments to be deployed and able to host their services on, and roughly 6,000 hours of our reliability engineers on the manual labor for deploying such environment. The first stat here is kind of a rough average on the time it would take to deploy the resources on the manual scale versus this automated way with our app control plane platform. This is a bit of an architectural bird view of the platform itself. So in the left, we can see the developer would start on its application request on its developer portal, mainly start with Backstage. That would be reflected as an application definition that would get in turn transformed via our internal developer tools into what you see there as a bicep representation, which is kind of an application definition for radius. That would be pushed into a GitOps repository that would be reconciled via Flux and hosted on our cluster environments. After that, Radius would manage that representation itself and split it into some components we had previously defined on that bicep definition. And those components would map out roughly one-to-one directly with cross-plane compositions to manage logical segments of our environments, albeit, for example, a database would be a composition, cache would be a composition, identity to manage management policies, ownership of resources on our cloud providers as well. That would be another composition. So yeah, we would divide it, segment the compositions logically like that. You see Terraform mentioned, stated there. I haven't mentioned it yet. I'll get to it briefly. But basically, being in a regulated bank meant we had to do a lot of compliance logic wiring into each resource that we wanted to provide in the cloud providers. So that plus all the security checks, all the extra resource that already existed wiring would mean hard complexity to express in functions patch and transform in cross-plane compositions. I don't know if you're very familiar with that, but we had a few troubles in the initial development because of it. So what did we do? We already had a big, robust infrastructure as code platform with Terraform. So basically here you just see two basic examples of directory trees just to express kind of how we operated on our infrastructure as code platform with Terraform. So basically this is how we manually vendored and processed resource requests from the developers onto our infrastructure. So namely, we'd have a specific modules repo where we'd store those Terraform modules with the complex compliance wiring logic inside of them. And then we'd vendor out in our Yak specific repo. You can see that workloads directory there. We would just have a big list of each workload, and inside we would save, instantiate, and then save each model ran for each workload. So this meant we already had all that complex logic and wiring on Terraform itself. So the design choice here was to kind of adapt and try to mitigate the development pains early on the first iteration of the app control plane via a new resource called Workspace, available through provider-terraform for Crossplane. So basically you just have the module code inside a workspace that would be managed by a composition later on. And this led us to avoid having to rewrite that whole complex logic wiring into the composition itself via function patch and transform, and just invoke the module in the composition like so. This is quite a heavily segmented example, but you can see there, you would just, that is the part of a composition, let's say. You would just have the workspace inside with the module via a git source or just hard stated there, and would save us the time of rewriting that into the composition itself. Okay, this was fine, this worked. This was a proven iteration that led us to the stats I showed you earlier. So this ran for a few years as such. And saved us a lot of time in the meanwhile. But it had some glaring and apparent issues. I'll state now. So basically, the pains we felt the most here were all time gains on troubleshooting processes that were kind of piling on every day and trying and somewhat mitigating the time we were saving due to this whole automated process. So basically, due to how the workspace is wired, you don't have clear visibility into the resources that the workspace is managing if you're doing that via a composition. So you have kind of an abstraction layer on top of the composition itself. It gets cloudier on the resources you're actually managing on that composition. You would have as well, that piled on the troubleshooting processes, because it was just another step that the SREs had to take while they were troubleshooting some incidents and adding time to that. We had some scaling issues as well due to our environment configs. We couldn't scale provider instances that well. And when we got to a certain number of workspaces, it kind of took about 30 to 40 minutes of reconciliation time for each workspace to complete or to even activate. So that took a big toll on the troubleshooting time or time to fix certain issues as well. And yeah, it piled on all this to kind of annihilate somewhat the time gains we had from this automation process. But the solution here was clear. The the obvious thing to do here would be, oh, sorry, yeah, this is just an example of that opaqueness I was talking to you about, or when you have a resource in a bad state, you can't directly view it. You need to perform a few more steps in order to get the resource state or the real resource state. And as I was saying, the solution here would be to migrate to the native providers. Okay, so when we decided to tackle and do this migration, we soon knew it would be a bit of a heavy workload to go through. And we made some design choices early on before continuing with the V2 development process. So basically, we would adopt the native providers. We would ensure all the resources we were using on the Terraform provider were available on the native Azure, which was the cloud provider we mostly use. We would use function compositions instead of the classical way to express compositions in Crossplane. So we would use a more programmatic code to express those compositions, enriching our capabilities of expressing these compliance logic within these resources and security barriers. And we would use a hard testable harness on the compositions as well. It was somewhat of a pain to on the first iteration to kind of do patches and minor versions without a robust and solid testing harness to maintain those compositions. So it became every day we wanted to add a new patch to composition. It became harder to regression test and make sure we wouldn't introduce new bugs into compositions. So we made sure to have this harness pretty well defined before we tackled the compositions. And we would also know that it would require a big migration from the old compositions to the new ones when the new ones would be developed. So we kind of set all these goals into one for this new version. Okay, so on the development of the new compositions, we had to leverage this AI power. I know, AI again. To mitigate a bit of the development time, we had to leverage a lot of the AI enablement to deliver a first iteration of this new style of compositions. But the thing is, we already had pretty good context onto what we wanted the compositions to be initially, due to all that logic being expressed in the Terraform modules themselves. So we supplied the modules logic to the agent's context in order to give us a really good first draft on the compositions themselves. No worries. That accompanied with good development standards on the compositions, solid documentation on function composition development, official documentation, and again I state, a really robust test suite that can iterate rapidly over agentic development and do really fast regression tests, enable us to have really great speed in developing this new version of the compositions. Okay, here is just the strategy we used to migrate from the old ones to the new. Basically using a Crossplane tool called for importing the existing resources. This is just a simple flow. So basically, we would still have the old compositions in place. We would launch the new ones on observe mode. The native MRs would then, from the new compositions, would then import the existing resources that were managed by the old compositions. And after that, we just take the new compositions would take the active management, and we could therefore decommission the old ones. All right, so here we have just a brief description of what our friend Yury is going to show you all in a demo. It's just basically showing the life cycle of how we operated this platform from the old style to the new on a basic SQL resource, just to give you guys a cool showcase. So, stage is yours.
Thank you, Gonçalo. Thanks a lot for the great context. So I'll try to run this semi-live demo. Why it's semi-live? Because I pre-cached the output to be independent of the conference networking, learning hard way from the last KubeCon. So I have a repo of well-tested code that works end-to-end. How the font looks like on the back rows, is that okay? Yeah? Thank you. So I'll proceed with this side. So the demo repo contains the stages of the migrations that try to represent the actual real multi-year migrations that we practice in the bank. And this demo script will guide us through those stages. So we start with a pure Terraform. Nothing special here. The only things that we need to remember is that we need to be compliant within the bank. So we need to carry over these compliance stacks across the implementation, across all the stages. So that's just the thing to remember, and we will return to it a bit later. Itself, it's just a Terraform model, so some managed instance, a database managed instance, plus associated networking, Terraform stuff, and we want to migrate from it. The main goal is to migrate to cross-plane-based abstraction, cross-plane-based logic, meanwhile keeping the core intact, right? So it's already deployed. So how to do that? The first stage that we used within the bank is to use a provider Kubernetes, as Gonçalo mentioned. So with provider Terraform, you have an ability to put Terraform application continuous behind the special Kubernetes resource called workspace, and this way you have a control plane continually applying your Terraform code. So it's kind of shortcut, and you can bootstrap your existing Terraform code this way in a pretty nice manner. In this example, I'm using remote style. I'm getting the Terraform model from some Git repo, and I parameterize it with Terraform vars, and everything is API-based with a kind workspace, right? So this kind of resource. So that is bare bone of the migration, the very first stage. This is already something that gets you into crossplane super quickly, but definitely you have all the Terraform luggage state file somewhere in the secret, usually if you're using Kubernetes backend, and this stuff is opaque, right? So you have a one workspace resource and multiple real external resources that are getting applied, and you have a limited visibility, limited control, and it works, but you can really hit the issues during the incident investigation, right? So this has like a mixed mode. Already one step towards crossplane, real crossplane, but still has a lot of Terraform-based limitations. So this is kind of Terraform bridge, and it's bare-bone workspace MR. Now the second real step towards your platform API is to create a custom XRD, custom API abstraction, in front of your workspace MR. So this way, we are going to actually create our custom platform design right away. So in this case, we hiding the workspace Terraform implementation completely behind our custom API line. So we have some database abstraction. We expose minimum amount of spec to reduce the cognitive load of our consumers. At the same time, if you look at the implementation, it will be same parameterized workspace. Beware, the patch and transform is not a recommendation here. I just trying to reproduce the actual sequence of the history here. Back in the times, the patch and transform was the best thing available for us, and that's how we proceeded with the bootstrap. Nowadays, you can use more powerful composition functions and languages. So we are wrapping the workspace MR, and if you render that stuff, so here's a cross-plane render. After the instantiation of this custom database XR, we will see the still parameterized workspace. So it's roughly the same stuff, but with the custom API and without the Terraform exposure. So now application team, our consumers, they will use our custom platform API, and they will never touch Terraform directly. So now we have a proper API line between the consumers and the platform builders. the consumers will use our custom database abstraction, and the platform builders will have a freedom and ability to evolve the solution behind the API line without breaking the contract. So API contract is a core part of the story here. So now, stage 3. Re-implement all the stuff already using modern composition functions and native providers. What we do here at this stage, again, important part, we are keeping the contract stable, right? So XRD travels across the stages. And what we are going to use here for the implementation is actually Python function. So if you quickly look here, it's some Python logic. We will use a Python as a generic purpose languages with loop and conditional, so you can express very powerful logic there. Again, it's like a weak recommendation from a standpoint, use a modern composition function, but you can use any language that is supported by Crossplane community.
Except Go templating?
KCL, except Go templating. Go templating is horrible, never use it. So in this stage 3, we are running still the same stable contract of X database. And when we render that stuff, we will see that we already have a composed resources, fine-grained composed resources, right? The managed instance itself and a set of networking resources. So now you have a proper Crossplane-based granularity, and nothing is opaque anymore. It's not hidden, and you have if you do a bit tracing, you will see a proper reconciliation for each individual resource. You have a proper state tracking. Everything is asynchronous and just more reliable by design. So now it's a Crossplane native code. Cool, but we still have our production databases in this story running with a Terraform, provider-terraform, with a Terraform code behind the old XR, right? So this stage 3 is a pure R&D mode. We tested it in isolation, and we have a confidence that the new instantiated database working, but we still have stuff to migrate. So what we are going to do, we're going to extend our composition code to be able to import existing resources, to take over the ownership of existing stuff from external API. So again, we're starting always with the same contract, right? Same database. We never break it. It's the same API that travels across the stages, and we only can have a additive, non-breaking API changes here, so our consumers are always happy. Now that we need to teach that abstraction to actually import stuff. It's thanks to Azure predictable identifiers, we can derive the deterministic IDs from a Terraform code and reproduce them in a composition logic, and use a standard external name import stuff dynamically within a composition. So the logic will be simple. So when you instantiate the new stuff, the resource is not going to be there. It will be created. If the existing identifier is there, then it will try to import it. So that's how every Crossplane provider works in that regard. So. And the benefit of that is that you didn't need to have a special conditionals, right? So you propagate these external names accordingly, and providers will figure the import out. Now, the second thing that is important for the migration story, we have a management policies on each fine-grained Crossplane resource, and we can control what Crossplane provider can do with those resources. And naturally, for the first migration, we just do the observe-only stuff. So we will add one additional non-breaking field to the API with observe-only true. That's an optional field, right? And this way, we will command to our composition, to our abstraction, and thanks to the composition logic, it will react to this observe-only field, and it will set associated management policies. So that's how it will work. If you run the render here, we use this observe-only true as a part of the spec, and the important things that it will do, if you look at the desired composed array state, it will set the management policies across all composed resources. So now it's purely read-only, but you already can test the migration, right? You can test the import. And if everything is getting ready to like sync true, ready true, then you have a confidence in your implementation from an import standpoint as well. And you can flip the observe-only field to false that is actually default in this implementation, right? And the composition logic are going to expose the whole control array over the management policies here. So now Crossplane is going to take over the full ownership of the previously existing infrastructure. And at this stage, you can properly observe it, already imported resources. So we are not starting from scratch, we are migrating existing infra, and eventually fully deprecate the Terraform-based implementation, switching it back to observe only 2 and fully delete it. So again, this pattern is pretty straightforward. First, you import in a read-only mode, observing that everything is fine, then flipping the flag. Composition logic will do it for you. You need no external tooling to achieving this this process, and no like extra roundbooks. Just the composition logic will do automatically the import procedure, and you don't need a special tools or something like that on top. So everything encapsulated behind the API line. Now, as migration is done, a bank auditor needs some higher level view how the migration is going. And that's what brings us back to our original text, the compliance, right? So we have this managed by Terraform tag that is set both within a control plane on a Kubernetes resource and also on external resources, Azure tag in this specific implementation case. And that's how we can track the actual state of the implementation. It is also part of the composition logic. And we can explicitly say either we are on a Terraform itself or on Terraform bridge or eventually Crossplane native implementation. And we can query both the state of migration through Kubernetes API and also some external resource query by auditors on an actual Azure API in a cloud. So that's how it works. A quick recap, like 5 stages. Stage 0 is Terraform itself. Then we're putting the Terraform as a Kubernetes resource of workspace. Then we're creating the API in front of it, and eventually migrating to the Crossplane native implementation plus automated import. That's how it goes. One core point, the core XR custom abstraction is always stable, and your consumers are happy and they're consuming the stable API contract. That's it for the demo. Thank you so much. And Gonçalo, the stage is yours again.
Mine again. Thank you for that legendary demo. So, final words. So here I just wanted to incentivize folks. I see a few faces, so maybe you're feeling the same pains or just curious on the process. Few parting words. We leveraged this initially the Terraform embedded logic into the compositions, but later we could also embed this tech debt as context to provide the agents for the new compositions, which kind of really accelerated us. And that became a really good tool in our development flow. Also, the tools are here. As you saw, we have the necessary migration tools already available. The path became really clear after that. So it was just more a matter of doing the work than designing it. And yeah, if you're feeling the same pains, have no fear. Tools are here to help, and good luck. That's it.
Thank you so much.